June 6, 1944. Dawn breaks over Omaha Beach. A young German soldier named Heinrich Severloh takes his place behind a machine gun. He's 20 years old, a farmer's son. 2 years ago, he was working the land in Lower Saxony. Now he sits in a concrete bunker 40 meters above the beach, watching the largest invasion force ever assembled approach through the morning fog. Below him, over 5,000 ships, more than 11,000 aircraft, 156,000 soldiers preparing to storm the coast. Severloh's weapon is an MG-42. He's trained with it, practiced with it, but he's never aimed it at another human being. That's about to change. When the landing craft ramps drop at 6:30 a.m., American soldiers pour into the water. They struggle forward through chest-deep waves, weighed down by equipment, completely exposed on the open beach. Severloh opens fire. The sound is unlike anything else in warfare, not the familiar chatter of other machine guns. This weapon screams, a continuous, tearing roar, 1,200 bullets every minute, so fast that individual shots blur together into one terrible sound. Over the next 9 hours, Severloh will fire more than 13,000 rounds. They'll call him the Beast of Omaha. But here's the remarkable thing about his weapon. It wasn't created by military experts or famous arms manufacturers. The MG-42 was designed by a man who'd never been in combat, a manufacturing engineer whose company made household lanterns. His innovation would change warfare forever, and it started with a simple question that nobody else was asking. Let's go back to 1934. Germany introduces a new concept, one machine gun for every job, light enough to carry, powerful enough for defense, adaptable enough for vehicles and aircraft. They call it the universal machine gun. The MG-34 becomes reality. It's brilliant, advanced, fast-firing, versatile. It's also a nightmare to build. Every part needs a skilled machinist. Every component must be precisely cut from solid steel blocks. One gun takes 150 hours of work. That's nearly a month of full-time labor for a single weapon. The cost? 327 Reichsmarks, more than 2 months' salary for an average worker. Worse, each gun devours 49 kilograms of high-grade steel, materials Germany has to import. By 1937, military planners realize they have a crisis. They're building an army. They can't produce enough machine guns to arm it. The math simply doesn't work. So they issue a challenge, create a new gun with the same performance but much easier to manufacture. 2 prestigious weapons companies jump at the opportunity. Rheinmetall Borsig, Steyr, both have decades of experience. Both have famous reputations. Then there's the third company, a small factory in a Saxon town nobody's heard of. They make pressed metal products. Their bestseller, lanterns. They've never touched a weapon. Dr. Werner Gruner isn't what you'd call a weapons expert. Born in 1904 to a schoolteacher's family, Gruner studied mechanical engineering at Dresden's Technical University. His specialty, mass production, how to make things efficiently. He spent years researching manufacturing techniques, then joined the lamp factory as a technical designer. Guns, never designed one. Combat, never seen it. Military service, not a day. When his company receives the contract to develop a machine gun, Gruner could approach it like the weapons experts, trying to refine existing designs, improve traditional methods. He doesn't. Instead, he enrolls in a military machine gun course. He trains alongside soldiers, fires thousands of practice rounds, learns how troops actually use these weapons in the field. He asks questions the experts never consider. What breaks most often? What's hard to fix during battle? What makes soldiers angry about their equipment? Then he returns to his factory and asks the real question, what if we stop trying to make a better gun the traditional way? What if we make a gun that's better suited to how we actually manufacture things? Traditional machine guns use subtractive manufacturing. Start with a big block of expensive steel. Cut away everything you don't need. It's slow, wasteful, requires master craftsmen. Gruner proposes the opposite, stamped sheet metal, the same process they use for lanterns, Take flat sheets, press them into shapes with hydraulic dies. Fast, efficient, less waste. Workers don't need years of training. The weapons experts laugh. Sheet metal, for a machine gun, the forces involved would tear it apart. It'll jam, it'll fail, it's ridiculous. Gruner sets out to prove them wrong, working with a small team. Including a talented designer named Kurt Horn from Morse, Gruner creates something revolutionary. Almost everything is stamped sheet metal. Only the most stressed parts, barrel, bolt, a few critical pieces, are traditionally machined. Everything else, stamped, pressed, riveted, welded together. He designs a new locking system using rollers. Elegant, simple, perfect for stamped construction. October 1937. 3 companies submit their proposals. The 2 weapons manufacturers offer refined versions of conventional designs. Expensive, complex, built the traditional way, Gruner's lamp factory submits something completely different. The evaluation committee studies all 3. They choose the lamp factory. The first prototype needs work. The feed mechanism has issues. Barrel changes are too slow. Some parts wear out quickly during extended firing. Gruner's team refines everything methodically. Test. Adjust. Test again. They deliberately keep the external design similar to the MG34 so soldiers can transition easily. All the existing mounts and accessories will still work. February 1939. The improved prototype, now called MG39, undergoes extensive testing. The results shock everyone. That stamped construction the experts said would fail, it's actually tougher than the precision-machined MG34. More reliable, less sensitive to dirt and debris. It keeps firing in conditions that jam other guns. The looser tolerances of stamped parts actually help. Components flex slightly instead of cracking. Debris doesn't lock up the mechanism. The production numbers tell the story. Labor cut in half, 75 hours instead of 150. Materials cut nearly in half, 27 kilograms instead of 49. Cost down 24%, 250 Reichsmarks instead of 327. But there's something else, something unexpected. The new gun fires at 1,200 rounds per minute. Some versions hit 1,500. This isn't an accident, it's deliberate. German doctrine emphasizes pinning enemies down with overwhelming firepower. Military analysts studied footage and realized soldiers are only exposed for brief moments between cover. Maximum bullets in that window means maximum effectiveness. A gun firing 1,200 rounds per minute puts twice as many projectiles downrange as one firing 600. The engineering challenges are enormous. The bolt cycles 20 times per second, faster than the human eye can follow. The barrel heats up rapidly. Gruner's team solves each problem. Quick change barrels in under 6 seconds. A roller-driven feed mechanism that works flawlessly at extreme speeds. A design that sustains fire rates that would destroy other weapons. By 1941, combat trials on the Eastern Front confirm it. Soldiers love the new gun. Lighter, more reliable, easier to maintain. Devastating firepower. Early 1942, official acceptance. Full production begins. The MG42 enters the war. May 1942. Libya. The Battle of Gazala. British troops encounter the new weapon for the first time. The sound stops them cold. Human ears can't distinguish individual shots at that speed. Your brain can't process 20 separate bangs per second. Instead of rat-tat-tat, you hear something continuous. A tearing noise, like fabric ripping, a buzzsaw cutting wood. The British call it Spandau. Americans call it Hitler's buzzsaw. Russians call it the linoleum ripper. German soldiers have their own names: Bone Saw, Hitler's Saw, the Singing Saw. Production scales up rapidly. 1942. Nearly 18,000 guns. 1943. Over 116,000. 1944. More than 211,000. Despite Allied bombing campaigns. 1945. 61,000 more, even as Germany collapses. Total, over 400,000 MG42s. The psychological impact on Allied soldiers is severe. Veterans describe visceral, gut-level fear. The sound triggers something primal. Training helps, but it doesn't erase the terror, and the reality matches the fear. 30 seconds of sustained fire puts 600 bullets into the target zone. Against exposed infantry, it's catastrophic. The weapon changes German tactics fundamentally. Other armies build squads around riflemen with machine guns for support. Germany builds squads around the machine gun. 6-man crews. Everything focused on keeping that gun firing. Ammunition consumption is enormous, but results justify it. Single positions dominate hundreds of meters of open ground. On the Eastern Front, Soviet attacks shatter against walls of automatic fire. At Monte Cassino in Italy, the monastery holds for 4 months against repeated Allied assaults. MG-42 positions cut down every wave. After D-Day in Normandy, the hedgerows become killing zones. The thick vegetation creates natural corridors. An MG-42 at the end of a lane stops entire companies. American infantry learn to hit the ground instantly when they hear that distinctive sound. The U.S. War Department produces a training film specifically to address the fear. Automatic weapons, American versus German. The narrator insists American weapons are better, more accurate, more controllable. The German gun's bark is worse than its bite. Historians later note this is propaganda, not reality. The MG-42 bite is absolutely devastating. Tens of thousands of Allied casualties. June 6, 1944, Heinrich Severloh demonstrates exactly what the weapon can do. As landing craft approach, he begins firing, controlled bursts, sweeping the waterline, men fall, he keeps firing. His assistant feeds ammunition. When barrels overheat, they swap them out. Fresh belts keep coming from storage. The Americans in the water can't fight back. They're struggling through surf, carrying heavy gear. Many are seasick, weak, disoriented, rifles waterlogged. The naval bombardment that should have suppressed German positions mostly missed. Severloh fires for hours. Later, he describes how his mind detached from what he was doing. The shapes on the beach stopped being men, they became targets. Abstract. The gun's speed let him engage so many so quickly that his brain retreated from the horror. 13,500 rounds, plus 400 more from his rifle during barrel changes. Omaha Beach casualties exceed 2,000 on D-Day. Severloh's position accounts for a significant portion. His claim of over 1,000, possibly 2,000 kills remains debated. Some historians find the number implausible. But what's certain, MG-42 positions devastated the assault waves. Severloh's bunker was among the deadliest. After the war, American military planners study captured MG-42s extensively. They strip them down, measure everything, test relentlessly. They note the brilliant feed mechanism, the superior barrel change system, the proof that stamped construction works. Late 1940s, development begins on a new American machine gun. The design borrows heavily from German innovations. The operating system comes from the FG-42 paratroop rifle, the feed mechanism, straight from the MG-42, the philosophy of stamped construction, Gruner's work. The M60 enters service. American troops carry it through Vietnam. They call it the Pig. It serves for decades despite reliability issues. The Belgian FN MAG, which America later adopts as the M240, also owes design debt to the MG-42 concept. The whole idea of a general-purpose machine gun comes from German thinking. France's MAS-52 copies the feed system directly. Switzerland's MG-51 is essentially a refined MG-42. Austria's MG-74. Spain's Setmi Amili. Yugoslavia produces it as the M53 using captured German equipment. But the most direct descendant is German. When West Germany rearms in the late 1950s as NATO forms, the new Bundeswehr needs a machine gun. The choice is obvious. Most officers and senior enlisted are Wehrmacht veterans who carried MG-42s through the war. They want that weapon back. Problem: the Soviets captured all the original documentation. Factories were destroyed or dismantled. The workforce scattered. Germany has to reverse engineer its own weapon. They obtain an MG-42 from an American museum. Engineers disassemble it completely, measure every part to thousandths of a millimeter, create new drawings, design new tooling. The government pays royalties to Grossfuss for the manufacturing rights. Gruner's knowledge remains legally protected decades later. The MG-1 enters production. Rechambered for NATO 7. 62x51mm cartridge. Improvements lead to the MG-1A1, then MG-1A2, finally the MG-3 in 1968. The MG-3 is nearly identical to the original MG-42. Same construction, same mechanisms, same incredible fire rate. Parts between a 1943 MG-42 and a modern MG-3 are interchangeable. Over 1 million units produced worldwide. Licensed to Italy, Greece, Iran, Pakistan, Spain, Turkey, others, serving in conflicts from the Cold War through today. Over 40 countries use variants. 80 years later, weapons descended from Gruner's design remain in active service. The German Bundeswehr only began replacing it with the HK MG5 in the 2020s. Even then, vehicle-mounted MG3s continue because newer guns don't fit the old mounts. Turkish forces use MG3 variants today. Pakistani troops carry them. Greek soldiers maintain them. The weapon that terrified D-Day soldiers still serves. Few designs prove this enduring. Werner Gruner survived the war. He settled in Dresden in what became East Germany. His manufacturing expertise proved valuable to the communist government rebuilding industry. He became a professor at Dresden's Technical University, where he'd studied as a young man. Rose to become rector from 1950 to 1961. Trained new generations of engineers in the techniques he developed. East Germany honored him repeatedly. Orders, prizes. Named honorary senator of the university in 1979. He died June 29, 1995, at 91. His obituaries mentioned his academic career, his contributions to manufacturing technology, his service as university rector. They didn't dwell on the weapon that killed tens of thousands. Heinrich Severloh also survived, captured shortly after D-Day, prisoner of war, released after German surrender, returned to farming in northern Germany. For decades, he stayed silent about Omaha Beach. The memories haunted him, nightmares about the men he killed. Questions about whether he was a war criminal, whether firing at soldiers who couldn't fight back was atrocity. He struggled to reconcile what he'd done with his self-image as a decent person. He followed orders, defended his position, did what soldiers do, but he'd killed hundreds, maybe thousands, whose only crime was wearing a different uniform. Severloh reads The Longest Day by Cornelius Ryan. He discovers the story of David Silva, 19 years old. 29th Infantry Division, shot 3 times in the chest landing on Omaha Beach. Silva survived, became a Catholic priest in 1954. By the early 1960s, served as a military chaplain in Germany. Severloh tracks him down, arranges a meeting. The two men who'd been enemies on that terrible morning finally meet face to face. They shake hands, talk about the war, their experiences, the years after. They find some measure of peace by acknowledging each other's humanity. Both were young men caught in forces beyond their control. Severloh eventually publishes a memoir, WN62. He describes his time at Omaha Beach in detail many readers find difficult to process. He doesn't glorify anything. He simply describes what happened. Heinrich Severloh died January 14, 2006, at 82. His memoir remains in print. The MG-42 transformed how militaries think about machine guns. Before 1942, armies maintained strict categories: light guns for mobility, heavy guns for defense, different weapons, different tactics, different supply chains. The MG-42 proved one weapon could do everything effectively. The general-purpose concept became universal doctrine. Today, no major military separates these functions like they once did. The weapon also proved the power of manufacturing innovation. Gruner's approach, designing for production from the start instead of designing first and figuring out manufacturing later, influenced procurement for generations. Design for manufacturing is now standard in weapons development. Perhaps most importantly, the MG42 showed that deep expertise in a specific field matters less than ability to solve problems differently. A mechanical engineer specializing in lamp manufacturing created one of history's most effective infantry weapons. He succeeded because he approached the problem from an angle conventional designers never considered. He asked different questions, found answers the experts missed. The factories are gone. The company no longer exists. The workers who stamped sheet metal into weapons have passed from memory. The engineers, the soldiers, the enemies, nearly all gone. But their creation endures. Every time an MG3 fires, every time an M240 opens up in combat, every time military planners discuss machine gun requirements, the influence persists. The weapon designed in a lamp factory still shapes warfare. That's how innovation works, not always through official programs or recognized experts. Sometimes through outsiders who ask different questions and discover answers everyone else overlooked. A factory making lanterns, an engineer who knew nothing about weapons, a simple idea about stamped metal that saved money per unit and ended up transforming military technology for nearly a century. The MG42 proved the best solutions don't always come from obvious sources. Sometimes they come from people who don't know enough to understand what's supposedly impossible. If this story interested you, please like this video. It helps us share more forgotten military history. Subscribe to continue exploring these overlooked chapters. Each story matters. Each deserves remembering. Leave a comment telling us where you're watching from. Our community spans continents and generations. Veterans, history enthusiasts, everyone, you're part of something meaningful. Thank you for watching. Thank you for keeping these stories alive.